Alright, so today we're going to look at 11-6, which is volume of cones and volume of pyramids. So we've done volume of cylinders, right? And we've done volumes of prisms. So we're going to derive our own formulas for volume of the cones and pyramids. So my first question to you is, I've got a cylinder and its represented cone. In other words, they have the same height, don't they? Right? And they have the same bases, don't they? Right? Are they going to have the same volume? No. What's the volume of this? What's the volume of this? What's its base? Pi r squared times the height, right? So pi r squared h, that's your volume. We derive the formula for volume of a cone based off of the volume of the cylinder. If I were to fill this with water, well, I won't fill it yet, and pour it in here, how many cones are going to fill this cylinder? Obviously the cylinder, or the cone is smaller than the cylinder, right? 2? 5? 2? Okay, here we go. Stand back in the front. I'm a little messy. There's 1. Do you think 2 is going to do it? The experiment's what? Been thrown? Oops, missed a little bit. Do you think full 3? This is why I'm not dressed nicely today. Just saying. Is that a full cup?
Yeah.
Okay. I don't think I'd make a very good bartender. So it was full 3, wasn't it? So this is what compared to this?
Whoopsies.
How many cones did it take to fill the cylinder? 3. So this is what fraction of this? 1/3. So what's the volume of this? 1/3 pi r squared h, right? Okay. Now I have a pyramid, correct? The pyramid and its cube, this is a square pyramid, are the same height, are they not? Okay. Do they have the same bases? Right? How many of these are going to fill up the cube? 2, 3, 4. 3 or 4. Alrighty. Ready? Oops! See why nobody says close. There's 1. What do you think? There's 1. Here goes 2. Full 3? Because I tricked you on the other one, right? That's full 3, right? Did I do this over your desk, Katie? No. Is this the same? I made a very big mess. So how many of these did it take to fill this? 3. So what's the volume of this in general? Area of the base times the height. So what's going to be the volume of this? 1/3 area of the base times the height. Now, before I turn out the lights, I want to emphasize where the height is, again, on the cone and the pyramid. Isn't it perpendicular to the base, straight through the middle? Right? And same thing with the pyramid, correct? Okay. So, now I'm throwing things. Alright, so the fun has ended. So sorry. Time for notes to begin. Mercy, if you get the lights, please. And I'm going to move my video camera. Thank you, my dear. All right. So camera's moving. All right, so I do have some notes for you. Let's let the lights focus. So go ahead and look at the actual surface area, volume of our cone and our pyramid. So is that what we expected to see? Study guide for you. And on the back of the study guide, you can do the problem that I'm about to pose here. And girls, those of you taking the quiz, if you can't see, especially you can go sit there by the seat. Okay, so now we're all set. So there's your formulas. And you can notice here that on the cone that they're using big B, but you should know to replace big B on the cone with pi r squared. You really don't need a separate volume formula for cones and cylinders, but for whatever reason they do give that to you. All right, so on the back of the study guide that I just handed out to you, bless you, I want you to use the formula and just put it in terms of pi. Because most of you probably don't have your calculators out, so just put it in terms of pi, what you think the volume of that cone is. Notice that they have it tilted on its side. But you're always looking for the perpendicular line to the radius or the diameter of that cone. Now, remember that you've done surface area of a cone also. What is this? What's this part of the cone right here? That's the slant height. So in your homework tonight, they might give you the slant height but not the height. When you did surface area, they gave you the height but not the slant height. How did you find the missing one that you needed? Daggers' theorem. So you might have to do that again today. But this is a straightforward answer, isn't it? So what's your volume for this? What pi? Well, your pi r squared, right? Your radius is 3, correct? 3 squared is 9. That's 9 times 4. And then divided by 3 because it's a third. 12, right? So they've got the decimal equivalency here, but it is 12 pi is the exact 12 pi centimeters cubed. And why is it centimeters cubed? Because we've got 2 centimeters here and 1 centimeter here, right? If you multiply by 3.14, you get 37.7. All right, then I want you to do this one. And I'll move it up. Is that fuzzy or is that just me? It's just me, isn't it? All right, so you have, you don't have to write down the whole thing, just kind of sketch a picture of that pyramid. Is it a square pyramid? Nope, what is it? rectangular pyramid. So again, you still just have to find the area of the base times the height. Have they given you the height? Bless you. Is that what the 16 meters is? Okay. Be careful on pyramids. Pyramids are a lot more confusing than cones. Pyramids, they can give you the lateral edge. They can give you the slant height, which is neither of what you need for volume. What's the distance from here to here? If the whole distance is 5, what's the distance from here to here? 2.5. What might happen on at least one of your problems tonight is you might have to do Pythagoras theorem twice, or if you end up having a square here, and they give you from here to here, isn't this part of the diagonal? They might give you the lateral edge, and they might give you part of the diagonal of the square. Squares form what type of triangle when you have a full diagonal? Squares. 45, 45, 90. You might have to pull in that knowledge of a special right triangle in order to help you solve. If you have this kind of diagonal triangle in here, you might have to pull that in to help you solve, and it would avoid you having to do Pythagoras theorem twice. It would be a shortcut to that kind of problem. So I'll guarantee you're going to have that question tomorrow. But think about those things in those situations. For some of you, it's hard to see that three-dimensional figure on 2D paper. So area of the base is what? 20 times the height is what? What's 20 times 6? What? 120, and then divided by 3. 40. So isn't it 40 centimeters cubed? All right, now look at your study guide. And I do want you to highlight your formulas up here. And if you want to the right here, you can put, it's also equal to 1/3 pi r squared h. But essentially the volume of any cone or pyramid is 1/3 area of the base times the height. So volume is fairly simple, but of course there can be some issues depending upon what they give you, right? So let's look at a couple problems here. A little fuzzy, a lot fuzzy. Give it one more click. There we go. Okay. So on this one's straightforward. We're not going to do that one. This one's straightforward, right? What about this one? What's wrong with this one? Right, you need the radius. So let's go ahead and look at that one. And it might be handy if we had what? Only because most of you don't know what 26 times 26 is, correct? Okay. So use Pythagoras theorem to find your missing dimension. So I'm going to call this r, since that's what I want it to be. So I've got 24 squared plus r squared. My hypotenuse is always across from 90 degrees. It's 26 squared. There we go. All right, so then, I hope that wasn't cracking of gum. It's really loud. So it would be helpful if I turned it on, huh? So 24 squared is 576. And then 26 squared is 676. I subtract the 576, r squared is 100, so what's r? 10 meters, right? Now volume should be a piece of cake, correct? So we're going to find volume is equal to 1/3 pi r squared h, because that's a cone. So it's equal to 1/3 pi times, my radius we just found was 10 meters, and my height is what? 24 meters. Now if you weren't using a calculator, I would take 3 and divide it into 24, and I would get 8. And 100 squared, or 10 squared is 100, right? Times 8 would be 800. So your exact volume would be 800 pi, and then it would be meters cubed, because you have meters squared here times meters. Then if I want to see what its approximation is, I'm going to take 800 and multiply it by 3.14. Again, your book might use the pi button. They kind of go back and forth. We're just going to remain consistent and do 3.14. So we actually get 2,512 meters cubed for our volume. So there's our two possibilities for our answers. Then I'd like to do 3 with you. What kind of a thing is that? Number 3. Triangular pyramid. So the volume formula for a pyramid is 1/3 big B H. So we've got to find big B and H. Did they give us H? Yeah, this is our H. So thankfully that's done. And then what kind of a triangular base is this? It's a right triangle. What have you learned about a right triangle and its area? What's the base and the height of that right triangle? The legs, right? Do I have both legs? Yep. Seth is saying that he thinks a right angle goes to here. It looks like that's what it is, but it actually is going to this down here. Because if I don't have this right angle here, do I have any way of finding the height or base of this triangle if it's not a right triangle? So we're going to have to assume, and sometimes it's hard to see, and so you might have to ask those questions, where does that right angle really belong? But it does belong to the base. So we're going to take big B is equal to 1/2 base of the triangle times the height of the triangle. Height of the triangle is different than height of the pyramid. So plug in what you know. I'm going to use 18 inches for my base and 22 inches for my height. So 0.5 times 18 times 22. Get 198 inches squared. So do I have everything I need? So volume equals 1/3, parentheses, parentheses. For big B, we're putting in 198 inches squared. And for height, we're going to put in 13 inches. So on my handy dandy calculator, I am going to put, I'm not going to use, here's the problem. What do you think people might use as a decimal equivalency for 1/3? 0.3 or 0.33? Don't ever do that. Is that accurate? No. So what you're going to have to do if you're going to use your calculator is multiply the 198 to the 13. And I get 2574, and then the very last thing you do is to divide by 3. That's the most accurate answer. Do not multiply by decimal equivalency, or you are going to get a wrong answer. And so I end up with 858. So volume is 858 inches squared times inches is inches cubed. Bless you. Now, I could do number 5 with you, but I'm just going to talk you through it. It's real simple. Unlike surface area, with volume, couldn't I fill this with like a foam and fill that cone with a foam and fill the cylinder with a foam? And separately, wouldn't they have their individual same volumes, and put together, wouldn't you just add their volumes together? So you're not having to subtract anything out like we had to with surface area. So you would just find the volume of your cone, find the volume of your cylinder, and add them together, right? All right, well, so let's look at 6. And I chose 6 for a reason, because it's a little bit more difficult. Why is that? Which one is difficult about this? The pyramid really is the difficult one. What are you missing from the pyramid? I'm missing the height of that pyramid. Do I know the base around the pyramid? It's 12 by 12, right? So it's a square pyramid. It's just like the example that I used, which is not within reaching distance, of finding the volume of the pyramid, square pyramid, and the cube, right? So we're going to have to find that. So our volume for this is 1/3 big B H. Well, big B should be easy to find, right? Let's go ahead and find big B. Isn't big B equal to side squared because it's a square? And my side lengths are 12 feet because that's 12 feet and that's 12 feet. And then I'm going to square that. So I get 144 feet squared. So there's big B. But we need to find the height. So the height, mind you, goes straight down here into the center. And then they've given me the lateral edge. So this is kind of what I was talking about in the earlier example. I'm going to go ahead and take a diagonal line straight to here. And this is a right triangle right here. This would represent the height. This is part or half of the diagonal of that square. And this is the lateral edge. There is a longer way that we could do this, but this is a shortcut. And you guys are very good at special right triangles. So let's just consider the whole square, and we're going to find that diagonal. If I know this diagonal, can I take half of it and let that be the leg of that right triangle? And if I know that leg, and I know what's this to the triangle? Leg or a hypotenuse? Hypotenuse. Then I can use Pythagoras' theorem to find that height. So let's use our special right triangle, because I'm going to go all the way across here. I'm going to use that whole diagonal from here to here. This whole diagonal. So I have a 45, 45, 90, right? My pattern is 1, 1, grad 2. And then I know that this side is 12 and this side is 12. And aren't those the legs of my right triangle? So both of my legs are 12 and 12. And I'm trying to find that diagonal. So we're going to solve this proportion here, which is fairly simple. If I cross multiply, I get x is equal to 12 rad 2. So I only want half of it though, right? Half of that diagonal is equal to what? Divide that by 2, don't you get 6 rad 2? So that's the leg here. So now I know that that leg is 6 radical 2 feet. Now I can apply Pythagoras' theorem to find the height. So I'm going to let this be my height. And we're going to say h squared plus, I'm going to square this leg, 6 radical 2, equals, and we're going to square this lateral edge here, which is the hypotenuse, 10. So I get h squared plus, when I square the 6, what do I get? 36. When I square the radical 2, what do I get? 2. So the whole thing is 72, right? Equals 100. What's 100 minus 72? What is it? 28. 28 and 72 does add up to 100. Is that a perfect square? No. So then I'm going to take the square root of both sides, and I get h is equal to, isn't 28 4 times 7? What's the square root of 4? So isn't it 2 radical 7 feet? That's my exact height. Now we're ready. So now we're going to put in our volume. I've run out of room just a smidge. Maybe I can squeeze it in there. I'll squeeze it in there. So volume is equal to 1/3 big B right here, 144 feet squared times our height. Our height is 2 radical 7 feet. Isn't 144 divisible by 3? Right? So here's what I would do in my calculator. If you want exact volume, because we have a radical involved, if you want exact volume, this is what you're going to do. I'm going to get my little handy dandy calculator in here. So I'm going to take my 144, I'm going to multiply it by the 2, and I get 288. So I just multiplied these two together here. Then I'm going to divide by 3, and I get 96. So my exact volume would be 96 radical 2 feet what? I'm going to squeeze it in there, feet cubed. That's my exact volume, right? That's a cube. And then if I want my decimal equivalency, then I'm going to take the square root of 2. Oh, is it 7? Sorry. I don't know where I keep getting 2. Thank you. So then, how about radical 7? I'm going to take radical 7, and I'm going to multiply it by 96. Oh, I don't think that actually, well, I think that worked. That's already done. Yep. All right, so 253.99. If I go out to the 10th, would it be 254? If I go out to 100th, then it'd be 0.99. So it's approximately equal to 254 feet cubed. So that's about as hard of a problem as you're going to get. It's a lot of work for that problem. Oh, am I done though? No, that's just the pyramid, right? Now the volume of the cube is very simple, isn't it? How do you find the volume of the cube? Area of the base, 12 times 12 times the height. So the volume of the cube, do this up to the left, volume of the cube, big B times H equals 12 feet squared times 12 feet. So I'm going to do 12 cubed in my calculator. 12 to the third. I get 1728 feet cubed. So my total volume is equal to, or I'm going to say approximately, because I'm going to go ahead and use my 254. If I wanted exact volume, wouldn't I say 1728 plus 96 rad 7 feet cubed? That would be my exact. But we're going to add this to it, so add 254. That's our decimal approximation. We have approximately 1982. So 1,982 feet cubed. That is our final volume. So, questions?